1-2. All right, so we're talking about some forces. We've been talking about the crust, talked about the forces. We could have, compression going on there, tension, shearing force going on the crust. But there's another force that acts on the crust, and this is gravity. Gravity is the attraction of any two objects for each other. Now, the crust has an attraction for the center of the earth, and so it gets pulled down. But the crust exists on top of this liquid inside of the earth, and this is the mantle. Okay, this is a liquid layer. And so the question becomes, why is it that the crust doesn't just drop right into the mantle? Well, you have to ask yourself, which do you think is more dense? Is the crust going to be more dense, or is the liquid mantle going to be more dense? So think about a second. Hopefully you said the mantle liquid was more dense, because remember, the more the dense something is, the better it drops. Remember the egg demonstration we did right at the beginning? All right, so if you have this crust, it has this force of gravity, but it doesn't sink because this is too dense, and that means that the mantle is pushing back up, and that keeps it in place. This keeping this force balanced so the crust doesn't sink into the mantle and the mantle doesn't shoot out, that balance is called isostasy. Isostasy. You can say it any way you want. I'm not going to grade you on it. But this isostasy, iso means same, and stasy, this comes from stasis, meaning to stay the same as well. So this force down is equal to this force up. And as long as that maintains, then it's not going to move. But what can change this force? All right, so if the force doesn't change, nothing happens. But what if we do change the force of the crust? And how could we do that? Well, what if we added more stuff? Just like a river, like the Mississippi River, adds all kinds of dirt and gunk onto the Gulf of Mexico. If you add more stuff, what happens to this force? Well, this force gets bigger. So you would think, all right, so this force gets bigger. So when this force gets bigger, it's going to push down in there and it's going to sink. So it sinks lower. Now this is really important to us because for years and years and years, St. Lawrence Seaway, the Mississippi River, the Ganges River, the Yellow River, all these large rivers all over the world, they flow and they take all kinds of dirt and rocks and they dump them into the ocean. And so and then that stuff just settles to the bottom. And you would think that eventually it would fill in, because that does happen with little lakes. When you have a stream, the stream eventually fills the little lake in and it goes away. There's no longer a stream now. It's a valley or a plain. But it doesn't happen to the ocean. And why is that? Well, there's so much stuff that gets put in here that this force gets so much bigger that it sinks lower. And that's why the oceans don't fill in. So instead of this filling in the ocean and it leveling out, the crust sinks down lower and it keeps the oceans at the same level. All right, so the oceans are just as deep now as they have been forever, even though there's things being dumped in there all the time. But this is also why there are parts in Europe that have risen, have gotten higher in elevation. And why do you think that happened? Well, if you think way back into the past, there's thought that Europe was covered by glaciers, okay? So when the glaciers were here, huge amount of force pushing down on the crust, so the crust right down into the mantle. Well, are there a whole bunch of glaciers now in Europe? No, not so much, maybe way, way up north. But most of Europe, there's no glaciers there. And so the water melted and it went away. So what did that do? It reduced this force. And so the mantle starts pushing the crust back up. And eventually it's going to come and it's going to be level one more time. So this is a really kind of cool thing. And we are going to be doing a lab on this. All right, I can't wait to see you guys tomorrow. Have a great night.